In this video, I'd like to talk to you about a data structure called trees, just like you find in the forest. So far, you probably know about some of the contiguous memory data structures like built-in arrays or vectors, right? And those are commonly drawn like this on a whiteboard or a sheet of paper. And you probably also know about linked lists, which are commonly drawn like this, where you have a series of nodes, and each node has a reference or a pointer to the next element within the list. Now, both of these are linear data structures, meaning that they're storing all this data linearly in order, right? Now, trees are a little bit different than these data structures, than vectors or built-in arrays, or even linked lists. So imagine you took something like a linked list, where each element can point to other elements, and you sort of represented it in a way that looked like this. This is a tree data structure. Now, a couple things to note. The first is that very similarly to our linked list, that just by having a reference to the very first element, we are able to access all of the other elements connected to it. With a tree data structure, something that looks similar to this, we have the exact same thing. Just based on this element here, based on this node, if we have access to this one, then we can access all of the other nodes that are connected to it. And we can use that for our sort of traversal and sorting and so on and so forth, right? So this data structure here has what's called a hierarchy associated with it. 14 is under 9, and 9 is under 2, and 2 is under 1. 3 is also under 1, and 5 is under 3, and 7 is under 5, right? This is this hierarchy of data that we have, which is really beneficial for something like this. So it would make sense to use a data structure along these lines for anything that requires some sort of hierarchy. You have elements that are contained within other elements, and then broader elements above those, right? So one really good example of this is if you had cities within states, and then those states were within different countries. That would give you this sort of hierarchy of information. And then you could say, tell me everything that's under 2, or tell me everything that's under France, and it would list, here are the 3 cities that are under France, and then under those cities there's other populations or neighborhoods or whatever they might be, right? That's a very hierarchical data structure, right? It's a lot easier to store that sort of representation in something like this, like a tree, than it would be in something like one of these linear data structures, right? This is also non-linear, meaning that each element points to more than one, right? So this first element here at the top is going to point to 2. This element over here on the left actually points to 3 different elements. And then some of these down here just point to 1, which actually, if we look at this portion just here, this 11, 12, 13, this probably looks very similar to this linked list, but it's kind of connected to the rest of this tree here, right? So this is a tree data structure. It gives you this nice hierarchy, and it's nonlinear, right? Now, there's a couple key terms and phrases that I want to make sure that everyone's aware of. So the first is this node up here. Well, I guess the first one is nodes, right? So this thing is comprised of nodes and connections. So each of these is called a node. Each of these lines between them is called a connection. And this may be very similar to how you were taught linked lists as well, is that it's comprised of a bunch of nodes with connections between them, right? The next thing, this one up here at the top, right? Here with linked lists, this is pretty commonly referred as the head node, right? Meaning it's at the very, very beginning of this data structure. Here in a tree, this is actually commonly referred to as the root node, meaning it's the base node that everything else is attached to, right? inside of a tree data structure, you would probably have a reference just to that, just to the root node, right? In the same way that inside of a linked list data structure, you'd probably just have a reference to this, the head data structure, or a pointer to a head element, and that's it, right? In a tree data structure, you might only have a reference or a pointer to this, the root node. So the next thing is leaf nodes. Leaf nodes are these. They're at the very bottom of the tree, right? They're at the very end. There's nothing else connected to them. These are our leaf nodes. These are all leaf nodes, 13, 14, 10, 8, and 6. And it's because they have no children attached to them, right? Now, children or child nodes are any node that is underneath a parent node. One is a parent to both 2 and 3. 3 is a parent to 5 and 4. And 5 and 4 are children of 3. Right? This is how we get this hierarchy associated with it. So we have our root node and then our leaf nodes, which are the opposite of each other. We have child nodes. All of these nodes are children to something. And most of these nodes are parents, except for the leaf nodes, right? The leaf nodes are defined as nodes that are not parents, nodes that don't have any children underneath them, right? The next phrase I want everyone to be aware of is the phrase branch. Now, a branch is sort of a whole section of a tree, right? You may call this entire thing a branch, right? Coming off of 2, there's this. It branches off down towards this 9, and it's going to encompass this entire thing, right? And then we also have this idea of subtrees, which are smaller trees contained within the larger tree, right? This here may be viewed as a subtree underneath the primary tree, underneath our root node, right? So this whole thing is a subtree. Now, some of you may already be thinking that you may be able to write some algorithms that operate on trees, right? If I write a function that operates on this root node, well, I could probably write a function that operates on this and treat this as a root node, which means I could probably write a function that treats this as a root node, right? And so you could see how there is some nice recursive functionality that probably comes out of developing these tree data structures like this, right? So let's recap real quick. So trees, they're nonlinear data structures. They have a hierarchy associated with them. They're comprised of a root node. Underneath that, there's a whole bunch of child nodes. There are leaf nodes down near the bottom, which means that these are nodes that don't have children associated with them, right? Nodes that have children are called parent nodes. We have branches, which are a complete branch. So this 9 is a whole branch off of 2, right, going all the way down. And then we have subtrees, which is like this entire section of this overall tree.